Hello, this is a demonstration of interpretation of data. I'm using the AQA syllabus S2, and to demonstrate this I'm going to use the January 2012 question 4. Now, what's really going on in these interpretation of data questions? Well, there's about 3 or 4. There's 3 core elements, and then there's a final bit which is more of a variant. Firstly, they're going to ask you to pick out a specific item of data from a table. They're going to give you some real life statistics and you've got to pick that out. Secondly, they're going to ask you to calculate a missing piece of data because I've taken something out of the table and you've got to work it out by making it all add up. Thirdly, they may well ask you to look for a rounding error and they'll point you towards it, but basically you're going to demonstrate something as a rounding error. Those are your 3 core elements you've got to do. Fourth, they're going to ask you either to calculate something like a max and or min or a mean, and they could also ask you as an alternate to that to describe a trend, and you'll have to just do that by looking at the data. So let's have a look at this question and demonstrate the first half to start off with. Okay, so as ever, first thing we do is read the question. Question 4 shows data relating to marital status of the adult population of the population of England and Wales during the period 1971 to 2006. And here's the table below that figure 1. So we've got data here and it's broken down into by age group, by year. So we're every 5 years, 1971 and 1976, and then the total population, so in the first year there's 36,818. Bear in mind up the top here that the numbers in England and Wales are in thousands, so that's actually 36 million we're looking at, 818,000. Okay, and then they've split it up into males, total of 17 million, and females 19 million, and then they've subdivided it as to their marital status here. So 4 million, 12 million, 187,000, 682,000. So you've got to be able to start by reading the table, interpret it. Take some time to look at the data in front of you before you get onto the questions. Okay, so working our way down the table, we've got data here from 1971 to 2006. Okay, so let's take our time now and start reading the question. Easy introductory question. Find a piece of data in the table. So it's important that you read this and you read it accurately. Please do underline the key words. So, A, little Roman 1. How many single males were there in England and Wales in 1981? Okay, so all we need to do is to take our time and go back to the table. So we're looking at single males in 1981. So here's our males area, there's our singles, so that we're in this column here, and now we're coming down to 1981, so we're going to intersect with the row for 1981. So here we have a value 5013, 5013, but you must go back and check what it's in and whether they've put it into thousands, millions, whatever. And here, if you remember up the top, if we go back and check, it's in thousands. So what they've actually given us is 5013 in thousands, so we need to add 3 more zeros, don't we? So we're actually looking here at 5,013,000. Okay, and for that you're going to get 2 marks. So you're going to get 1 mark for finding the right piece of data, and a second mark for converting that into from the data, the number that you've got in the table, to millions. Okay, let's have a look at part 2 of this question. The number of divorced females for 1976 has been omitted. Calculate the number which should be inserted into the table. So we've got to find the number. So let's go and see where it's missing. It says 1976. 1976. So there's our row with 1976 in. And what is missing? The number of divorced females. That square, that cell is empty. Okay, how are we going to find this? Well, we know in all these questions that there will be a total or a subtotal, and that here it's 19,545, and the subtotals must add up to it. So that's a pretty straightforward thing for us to do. So we've got to calculate. We know that the total is 19,545. What we've got to take away from it? Well, we know that the rest of the columns add 3,597 plus 12,538 plus 2,877. So that's the amount we can account for. And that adds up, if you put it in your calculator, to 19,012. Okay, so everything we can account for adds up to 19,012. So I'm going to have to take that away from 19,545, which is the total, take away what we do know, and we're left with 533. So our answer is going to be 533. But again, bearing in mind, looking back at the table, we're working in thousands. So that's 533 in thousands, so we've got to add the 3 zeros. So we've got 533,000, nearly 500,000. Again, pretty straightforward. You just need to read the data and bear in mind that there'll always be a total and some subtotals, and they'll only ask you a question that you can get the answer to. Okay, final part 3. The total population shown in the table for 1996 is not the sum of the total number of males and the total number of females. Assuming that the figures are correct, explain how this has happened. Okay, so let's go and have a look at the 1996 and look at the data. So the first thing they asked you, set out for us, is the total population shown for 1996. So what is the total population? Well, that's in the first column here, total population. And in 1996, we have a total population of 40827, that's in thousands. So that's 40 million, yeah. And they say it is not the sum of the total number of males. So what was the total number of males? Total number of males here is 19,614, so that's 19 million, plus the total number of females, which is 21,212 million, 21 million. Okay, so let's quickly add these figures up and see if we can explain what's going on here. So what have we got? If we add up the two totals of the males and females, I've got 19,614 plus 21,212, and if I add those up, I am going to get 40826. Now compare that to the total, which we saw earlier was 40827, versus what we've just worked out there as the subtotals is 40826. What's the difference? Difference is 1. So that's 1,000, because we had 1 and we know this is in thousands. So what do we think the reason for this is? It's a rounding. It's down to rounding. And we can explain a bit more detail, couldn't you? But basically you're sat there saying that the total was 4,827. The subtotals, the males, sorry, 19,614. 19,614. 19,614, and the females, just to make this a bit clearer, 21212, which add up to 40,082. Sorry, 82. Should have, I said 82 and wrote 28. 82826. Yep. So how we're going to describe that as in more clarity as a rounding error. This is like to be rounding. This is likely to be due to rounding. So the male and female and total have been rounded to the nearest thousand, 1000. There we go. And we should probably add to that, this can result in a difference of 1000. You could include an example at this point. If you took one that's just below the rounding, 1400 plus 2400 added together would give us 3800, and then if we did the rounding, first number would round down to 1000, the second one would round down to 2000, whereas the right hand side would round up, so it's going to go up to 4000. Yeah, so the two on the left would therefore give us would round down to 3000, and that one's going to round up to 4000, so they don't equal by the time they finish the rounding. So might be worth putting the example in there. Okay, so let's have a look at the second half of this question. These are very, very different, so I'm not sure how much benefit you'll get out of this, but it might be something you'd be interested in a sec. In this question, we're doing a number of description questions. So let's have a quick read of B1. Describe the trend shown by the number, it's in capitals, of females who are widowed. So let's go back and look at the data and pick out that information. Number of females who are widowed. So which column are we in? Number of females who are widowed. Let's do this in blue. Number of females who are widowed. So we're looking down this column here. That will start 281, 287, 29. This is going up, isn't it, at this point? 287, 29, 39, 29, 53. So that's been going up, hasn't it? That's going up. So you can put a little arrow in your own mind, so it'll help you remember. That's what I tend to do if I'm looking at a table. Going up. Then it starts to turn around at this point. It's gone down that year, gone down again, gone down. And that one's gone up slightly, hasn't it, at the end? So what are we going to say about this? Sorry, it's gone down. Apologies, I wasn't reading closely enough. That's one for you to be able to tell me I've got wrong. You're all shouting at the video. Okay, so it's gone up from 1971 to 1986. Yeah, 1971 to 1986, and then it's gone down to 2006. So factually, that's what you want to be saying here in describing the trend. So we're going to say on number one, we're going to say was number of females widowed. We're going to say rose from 1971 to, what was the date again? Don't hold too much in my head. 1986. And then it reduced from 1986 to 2006. There we go. 2 marks, 2 descriptors, 2 descriptions of that, isn't it? 2 parts of the trend. So that worked out pretty well, didn't it? Right. Next one. This is the bit with the calculation in. Showing, so with the necessary calculations, showing the necessary calculations, describe the trend shown by the proportion, underline in capitals here. Look, it's in bold rather. They put it in bold. So I'm going to underline it here so it's really clear. The proportion of males who are widowed. Okay, so what are we going to do? We're going to work out what those proportions are. Okay. What should we do? Should we do it as a percentage? Have we got a calculator? Let's get a calculator up. You would normally, wouldn't you? And you'd work those out. So let's quickly check again. We were looking at the proportion of males who are widowed. So let's have a look here. Here's the males. Here's the widows column. So there we are. We're looking at the widowed here. And what we're interested in is what proportion they all are. So let's do this as a percentage. And here the first number would be our 682, and that's out of a total of 563. So what does that come up with as a percent? And that comes out as 3.9%. Yeah, 682 divided by 17,563 times 100. What I'm going to do now is just put the other numbers on the screen. I'll do that while the video stopped so we can do it quickly, but I'm basically going to repeat that process. So there are numbers, and what we can see here is percentage wise there's a slow reduction, isn't there, over the period from 3.9% up here at the top. So there's our 3.9%. Here's our starting point, down to 3.4% as our finishing point in 2006. So let's write it out to answer the question. And it says showing the necessary calculations. So what we can do here is go number 2. The proportion has reduced. The proportion has reduced. Is it quickly or slowly? I think it's quite slowly, isn't it? It's not been a massive reduction from, what do we have, 3.9% in 1971. Now they asked us to do calculation, so let's just put the numbers there so they can see what we did. It's 187 divided by 17,563. There we go. To 3.4%, wasn't it? It's our other one in 2000, and was that 6? Just check it out, shall we? 2006, and here we've got 716 divided by 21126. It was 716, wasn't it? Let's just check that out again, make sure I've understood. I've got it correct before I throw you all. Yeah, 716. There we go. How about that? So how many points were we looking for there? They're going to give us 3 marks. They're going to probably give us one for working out and doing the calculations, one for doing accurate calculations, and finally one for saying that it's a reduction or reducing trend. Yeah, how about that? So there we are. That's the sort of question you're going to get is your parts. Okay, finally, as with the other videos, here's my quick summary of interpretation of data. Firstly, the first question is going to be pick out a specified item from the table. Make sure you've identified identified the piece of info you're looking for and that you've adjusted for its units. Make sure you've checked that you've picked out the right piece of data. Mark it up on your table. Do your column and your row and see where they intersect. And in order to get there, make sure you underline the key parts of the question so you can see exactly which part of the table they're interested in. Second question will be calculate a missing piece of data. It should all be there. It should be obvious which piece is missing because one of the cells will be empty and you can use the subtotals to calculate it. Third item, identify rounding errors and explain how they come about. Yeah, if you need to, use an example, but you should be able to do that. But remember, nearly all of these tables will be rounded to the nearest thousand or nearest million. They're not going to be in base units, so you can always see your rounding errors there. Fourth, carry out some form of calculation. They're going to ask you to find a max, a min. They could ask you to find a mean of a row of data. The other thing that in this question was a bit more complicated, they actually asked us to find the proportion, and effectively we calculated percentage. That's a more extreme version. And finally, they're going to ask you to comment on some form of trend. It could be an increase or a decrease. It could be the total's increasing or decreasing, or it could be that the proportion is increasing or decreasing. That's what you see in real life examples, and that's what they're looking for you to pick out. So they're not particularly complicated as long as you've read the data and you interpret it correctly, but it's worth taking time to familiarize yourself with the table first rather than just plunging into it. Try and understand what the table's talking about and how you can use that data. Then it will be much easier when you come to actually answer the questions. So once again, thank you for watching, and I hope that's of use.